So continuing on with lesson 4, we talked about what was a function, what wasn't a function. We said a function had to have one y value for every x value, which was tough to spot if it was points. We had that vertical line test, which allowed us to spot when it was a graph, whether it was a function or not. We're going to introduce to you today domain and range. So I've got the words written here. Domain. Domain is the list of all the x values of a graph or a function. It's the list of all the x values. The range is the list of all the y values. And when it's individual points, we're just going to list them. It's going to be trickier when the points are connected like a line. So example 1 says, find the domain and range. That's a line. That's going to be a bit tougher. We'll come back to it later. Instead, what I'd like you to do is I'd like you to skip all the way to example 2, which is, I think, the front of page 2. Right here. We already identified whether these are functions or not. Now what we're going to do is we're going to identify what the domain and the range of each of these are. So A, remember Carmelina, these are my x values. These are my y values. If I ask you for the domain, here's how we're going to write it. We're going to use a capital letter D for domain. And we're going to use fancy smancy set notation brackets, the curly ones. And we're going to list the x values. Just rattle them off. What are the x values that occur in example A? Brendan, you're right. Say it louder. Let's decide from now on, we'll always list them in order from smallest to biggest, so all of our answers look the same. So I'm going to say -2, comma, +1, comma, 3. That's the domain. What's the range of A? It's the y values, the outputs, the dependent variables, all different words for the same thing. What's the range? Just read them out. You're overcomplicated. What's the range?
12, 0.
Go in order, smallest to biggest.
-4, 0.
The range of this particular relation or function is negative, not a function, this particular relation is -4, 0, and 12. This function has x values, inputs, domain of -2, comma 1, comma 3. And it has a range, the possible output values are -4, 0, and 12. B. What's the domain? What are the x values that this function has? -3, -2, -1, 3, and 4. Right? What's the range, smallest to biggest? By the way, usually your domain, Brendan, usually your x values will be in order from smallest to biggest, because that's usually how we just stick them in. Not always, but usually. The range, you have to kind of look. What's the smallest one? 1, comma, 4, comma. I don't write it twice. It appears twice. I don't write it twice. Comma. What was that? Brandon, you had a question? Might have been a good one. Apparently not? Okay. Let's keep going, mister. C. The domain, now I've got to read it actually from the x coordinates. Start here and just work your way sideways all the way across. What are the x values that appear on this graph? Here's the first point. What's the x value that goes with it? What's the x value that goes with it? Read it. Okay, so my domain is going to have a negative 3. Keep going, keep going. Dunk, I run into another point. What's the x value that goes to that point? Not negative 2. There's nothing on negative, right? Negative 2 would be something there. There's nothing. This one, the domain does not include negative 2. Negative 1. Dunk, I run into another one. This point here, what's the x value that goes with this point? 0. What else? Keep going. 1. 2. The domain of that graph is negative 3, negative 1, 0, 1, 2, 3. What's the range? The range, Carmelina, is the heights. So I'm going to start at the bottom and just work my way up. And the first height that I run into, Carmelina, is this height right here. How high is that right there, that point? Negative 2. So range, first one I run into is negative 2. Keep going. What's the next height I run into? Right here? Yep, you're right. Is anything 0 high? Oop. Yep, right there. Yes. What's the next height I run into? 1. Twice, but I don't write it twice. Any other heights appear on this graph? That's the range. That's a terrible curly bracket. I can do better than that. So when there's points and they want the domain, you list, Katie, all of the x values that appear. You list all the y values that appear. Try doing D on your own. Try doing the domain. Try doing the range. I'll do it up here if you get stuck, but see if you can try it yourself. I got 3 elements in my domain. I got 5 numbers in my range, I think. Negative 3, negative 2, negative 1, no 0, 1, 2. Yep. Is that right, I think? I got a domain of negative 2, comma, negative 1, comma 2. Those are all the x values that appear. I got a range of negative 3, comma, negative 1, comma, negative 1, comma, 1, comma 2. Those are all the y values that appear. Domain and range. Problem. Don't write this next bit down, but here's the problem. What if instead of separate dots, what if they were connected? What if instead of separate dots, what if they were connected? Jordan, that means if I was, for example, looking at the domain, that x value appears, so does that x value, 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 so does that. Can I possibly list them all? So I can't list them separately when my graph is continuous. When my graph is discrete, like this, I can. When it's continuous, I need to come up with a better method. What I'm going to do when it's continuous is I'm going to tell you the smallest the graph gets, the biggest the graph gets, and I'm going to say it's everything between those values. Say what? We looked at the vertical line test here. It says to find the domain and range, I'd like you to turn the page and look at example 3. Is this a discrete graph? Are these points separate? No. So can I just list them all? Nope. You ready? I can do that. But instead of saying, tell me all the x values that appear on this graph, because I can't list them all, Graham, there's an infinite number. Every single decimal value in between each square also would appear. I ask, how far left does my graph go? How far left does this graph go? The smallest x value that appears is -3. I'm going to write that first. How far right does my graph go? Leave a space. The biggest x value is 4. And here's how you write everything between -3 and +4. You don't write everything between -3 and +4. Too much writing. We have math shorthand. To show that it is everything between -3 and +4, give me 1 second. So listen up, this is important. This is how you write all the x's in between -3 and 4. You write a -3, you write a -4. Domain is my x values, so I'm going to put an x right there in the middle. Put an x right there. And what I want to say at the same time is this. I want to say that x is bigger than -3 because it is all the x's to the right of -3. At the same time, I want to say that x is less than -4 because it is all of the x values less than -4. Here's how you write it. You put a less than sign there and a less than sign there. Say what? I'm going to write that down and I'll show you how that works. Don't write this next bit down. Here's what you're saying. Here's what you're saying. X is bigger than -3 to the right of -3. Don't write that blue part down. Are my x values bigger than to the right of -3? Yeah, hurry up. Sorry, guys. This is a key lesson. There's lots of distractions. Whispering, talking. Folks, I'm telling you, this is fundamental. It's important, so suck it up. Okay? Are all my x values to the right of -3? Yeah. At the same time, x is smaller than 4. Are all my x values smaller than 4? Yes. This is how you write an in-between statement. Let's try the range. How low does this graph go? Leave a space. How high does this graph go? Range is my y values. Is every single height between -3 and +4, is every single height used up? Are there any gaps? Nope. Then I want to say every single y value between -3 and +4, it's always going to be less than, less than. It's always going to be the one that looks like a capital L. That's what less than looks like, L for less than. Yes?
When you put the line underneath the
No.
less than sign, it doesn't touch negative.
Ah, okay, you're getting ahead, and I'm glad you asked. I was hoping nobody would, but I don't mind that you asked. Jake, you with me? Okay, for sure? Okay. The fact that there's a hollow point right there and right there was done deliberately. What I'm saying is we get closer and 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 closer, all the way infinitely close to 4. Never touch. How do I show that we want to touch there? Well, I'll color it in. So that's also going to be important. In fact, let's move on to B right now. B. Let's see if we can do the domain. Looks like the furthest x value is right here. What x value is that?
3.
-3? The rightmost x value is that. What value is that? 4. We're doing domain. Domain is your x values. It's bigger than -3. It's smaller than -4. But to show that it touches at -4, Graham, we want to really say that, don't write this down, x is smaller than or equal to positive 4. And the way we do that is we combine the smaller than and the equal sign. We combine them by putting half of an equal sign underneath. And I read that as less than or equal to, less than or touching, if I'm talking about a graph. That is saying, you know what x values this graph uses up? Everything between negative, not touching, negative 3, and positive 4, touching positive 4. Let's try the range. How low does this graph go? Touching? No, or equal to. Its range, its y values. How high does this graph go? Careful, it's not this point right here. How high does this graph go? 3. And I'm pretty sure it touches there. It looks like the ink overlaps, yes? So less than or equal to 3. We're going to come back to C. D. D. How far left does this graph go? Touching? Actually, it is because I designed it that way, but it will be clear that it's touching if I give you this on a test. It is or equal to. And it's domain tie, so it's x values. How far right does this graph go? Touching? Yes. What about the range? How far left does this graph go? Sorry, how far down? Range is vertical. How far down does this graph go? -1. Touching? Yep. How high does this graph go? It touches 2. Oh, come on, Mr. Dewey. C is a bit weirder. How far left does this graph go? -4. Don't write that down yet. Touching? Yeah, it is touching at -4. How far right does this graph go? Are there arrows on the end of this graph? What do those arrows mean? So how far right does it go? Infinity, positive infinity. I'm not going to write that. Here's how I'm going to write this domain, because it's not between two numbers. It's everything to the right of, everything to the right of what? -4 and touching. Now here's how I write that. X is bigger than or touching -4. Now, some kids have trouble remembering which way the greater than, less than signs point. Do you notice that if I draw an arrow in the direction that I want to go, that arrow happens to match what that sign looks like? Not a coincidence. If it was pointing, if it was less than pointing to the left, the arrow and the less than sign would also be pointing in that direction. If I confused you, don't freak out. We'll try a bunch more. All right, Schmarty pants. What's the range? How low does this graph go? Is there an arrow down here? So I think it's saying it keeps going and 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 how far does this graph get eventually? Begins with the letter I.
Infinity.
Negative infinity, but yeah. Oh, and Rob, same reasoning. How high does this graph go? Positive infinity. Okay? Don't write this down because this is too much writing. You could say everything between positive and negative infinity. Too much writing. We have a fancy schmancy phrase, a fancy schmancy way to write that. Stop clicking your pen, please. Or binder, or whatever that is. we write that as, we say that as all reals, which is short for all real numbers. Everything between negative infinity and positive infinity. We don't write that. That's too much writing. We say that, but we have an abbreviation for that. First of all, range, X or Y? Y belongs to the set of all reals. There's a symbol for that. The symbol for belongs to the set of is a capital letter C with a line in the middle, or you can think of it as a curvy capital letter E. It's a Greek letter epsilon for those of you who score, keep it home. And we use a capital letter R for the abbreviation for all reals. It's a lot to get, I know. Can you go all the way back to the first front page, please, where we had this graph here? Okay. That graph is kind of recreated, actually. Oh, no, never mind. We're going to come back to that. This graph, does it have arrows on the end of it?
Yes.
How far left does it go then? It's a trick question. Negative infinity. How far right? So if I was going to list the domain, it says, look at the example in warm-up number 1 and find the domain. I would say the domain was XER, all reals. How low does that graph go? Are there arrows on it? All the way down to negative infinity. How high does that graph go? Are there arrows on it? We would say the range was all reals, all y values. Now, if you write all reals, I'll figure out what you mean, but on the provincial exam, I guarantee that's probably the kind of notation that they'll use if you're picking from the multiple choice. You got to recognize it. Can you go to the bottom of the back of the next page? Sorry, the bottom of the front of the next page. This one right here where it says, look at the graph, ask yourself. This graph here, continuous or discrete? Separate points, or are they connected by a line? Discrete. So we're going to find the domain and range of this one. Are there arrows on the end? How far left does this graph go? How far left? -3. Less than. Touching? How do I know? Because the circle, the dot is what? Colored in. X. How far right does this graph go? Touching? That's the domain of that line. Let's try the range. How low does this graph go? Also -3. Touching? Yep. Range? Y. How high does this graph go? Touching? Yep. So we really have two main methods. If it's separate points, Carl, just list them. Like we did here. We didn't bother doing E because I didn't get hang of it, but like we did here. If it's connected, you got to ask, is it infinite or not? If it's infinite, if it's ending, if it terminates, you just say lowest, highest, in between, less than, and then Sarah asked, touching or not? If it goes forever in either direction, all reals. If it goes forever only in one direction, everything bigger than or smaller than whatever value. Let's try next page, this one here. For some reason, it went A, B, C. Can you do me a favor? Let's get this organized. A, B, C, D. I think you guys can call this graph E and this graph F. So let's do E. Okay. Domain. How far left-right does this graph go? This is a tough one. How far left does this graph go? -2. How far right does this graph also go? -2. In fact, what's the only x value that appears on this graph? This is a weird one in that the domain is just a single value, so I can list it, right? Is the range a single value? How low does this graph go? -infinity, because there's arrows. How high does this graph go? We called that one all reals. Y, range. Funky curly E, capital letter C with a line in the middle of it. R for reals, all reals. Everything. Every single possible height appears on this graph, but only one x value appears on this graph. Graph F. Ooh, wow. For what it's worth, this is called a hyperbola. It shows up, comets travel in hyperbolas when they circle around the Earth. The Portman Bridge arch, I believe, was a hyperbola before they stopped using it and replaced it with a new bridge. They show up all over. Oh, don't write this down. Pringles chips are three-dimensional hyperbolas, done intentionally because three-dimensional hyperbolas stack naturally. That's why you can stack so many Pringles chips into a Pringles container. It's a hyperbola. Arrows or not? Okay. How far left does this graph go? -infinity. How far right? You know what? I think my domain is going to be x for domain, but it's going to be all reals. What about my range? Now this is tough. How high does this graph go? Right here, how high is it going to go? How high is it going to go? Say it louder. Positive infinity. How low is it going to go? How low is, yeah, negative is down, right? How low is it going to go? Is it using up every single value, or is there kind of a gap in the middle here? Okay, the only way we can do this is to list two separate ranges. The upper one and the lower one. The upper one is, okay, just look at the upper graph. What's the lowest it gets? Everything above 2 and touching. How would I write that? Y, bigger than, greater than, 2 and touching. How will I do that lower graph? Everything below less than -1 and touching. That's a really tough one. Oh, by the way, graph F, function or not? One of the reasons it's tough to do the domain and range. Not a function. Graph E, function or not? Nope. What about graph A? Yeah. B? C? No. D? No. Okay. I'm going to modify things a little bit. I think I'm going to pass on example 4 for a second. What's your homework? You got a few things to throw at you. Try number 1. You can try number 2. Except you can cross out on the next page 2K and 2L. My friend who created this lesson, his kids all had graphing calculators, so you could graph that and then find the domain and range. We don't have that. I'm going to pass. No. 5, 7. And I got more for you. So your homework, not just the assignment, but I've given you 2 other things. So I've given you quiz 1. That is going to be due first thing on Tuesday. That's what you absolutely want to finish in class. But I gave you a second sheet as well. This is actually continuing what we did last day, interpreting graphs. So take a look at this. The punchline is, what kind of a monkey can fly? Here's what this says. Sketch 2 graphs for the situations. Match each number to one of the answer choices, then write the letter of your choice. So what? Here's the situation in number 1. Erica walked from home to a friend's house, watched TV for a while, and then walked back home. Graph number 1 is if you graph on the y-axis Erica's distance from home. Graph number 2 is if you graph speed. So remember last class we did that voting game? Okay, this is the same idea. We're going to do number 1 together, and I'm going to do the speed one first. Graph number 2, I'm going to do that one first. So what does it say? She walked, actually let's do distance first. It says Erica walked from home. So if she's walking from home, what does her distance from home start out at?
0.
I'm looking for a graph that starts out going through 0. Which means the answer to, could be either one of those. So she walked to her friend's house. What would happen to her distance from home as she walks to, Carl? Should be getting bigger. I'm looking for a graph that does this. Then she stays at her friend's for a while. Time keeps moving forwards, but what happens to her distance from home if she's staying in one spot? Okay, I'd be looking for something horizontal. And then what does it say? She walks back home. And, I think that one, yes? Because her distance would get back to 0. Now, what about speed? The second graph, it says, what's her speed? She walked. That would be a forward speed. Your distance would be increasing. Then what happens to her speed when she's at her friend's house? What would stops look like as a height? I don't think stable, because if you're 10 high, that means you're traveling at like 10 meters per second or something like that. I think if you're graphing speed, I think I'm looking for a graph that has a section where it touches. You know what? I think it's graph N. That's when she is at her friend's house, standing still. Speed is 0 speed. Walking, 0 speed. Walking again. And I don't know how high it is, maybe 5 meters per second or something like that. I don't know. So what you will do, what did we say graph number 1 was? Graph T? So put a T down at the bottom where there's a number 1. What did we say graph number 2 was? Graph N. Put an N down at the bottom where graph number 2 is. Some of these are tough. You may have to figure out the punchline and work your way backwards. Turn the page. Okay. Same idea for these ones here, where you have 2 situations, and each of these situations will match one of these graphs. So number 1 says, Roy rode his bike up a hill at a slow but steady speed, then went faster and faster as he rode down the other side. X equals the time, Y is the distance traveled. See if you can figure out which graph that would make the most sense of. And then graph number 2, same situation, X is time, Y is speed. These are tough. So, main homework, Carl, take home quiz for sure. Second homework, I would love to talk about this sheet on Tuesday too. If you don't get to the lesson domain and range, I'm going to continue domain and range on Tuesday anyhow, because I don't think the distraction level here was conducive to you learning it all that well, and it's a fundamental concept. It's important enough. I need to cram it down your throats in love. Any questions? You may have the remainder of the class to work.